Hey gang, as promised, I'm going to give you a little update or help on the UDP assignment. It's a little late, so I'll give you a little extra help more than I was actually planning. So hopefully this will get you along. So let's go into Blackboard. All right, so all I've done is I've gone into Blackboard, downloaded the two, saved them as Blackboard server.c, Blackboard client.c. It's straight off of Blackboard. So if you're downloading off Blackboard, putting it into text editor should look like this. I use TextMate. It allows you to get a little bit of an IDE friendly environment. So let's go in and take a look what we need to do. First, let's go in uh, and compile them and see what we get. So I'm going to compile this with GCC and standard equals C99, and it's going to be Blackboard client.c, and I'm going to output this as BBC, just BBC. So let's do that. You'll see the warnings. Let's do the same with the server. So GCC dash dash standard equals C99, and we're gonna do Blackboard server this time, and we're gonna output that to BBS, and we'll have that, and we'll have 5 warnings generated on that one. So cleaning up the warnings is just like before. Just go in and clean them up. That will certainly help you out. So now let's think about what we need to do. This is a UDP server. The UDP server and UDP client communicate through datagrams, and the assignment is to make this a reliable service. Well, if it needs to make a reliable service, you have to add ACK. So the question is, how are you going to add ACK? And so that could be, and we're not going to go through this, but that would be simply inside of your data, put a block of that data if you want to stay in the correct form. You could do 32 bytes of data that simply has a flag of ACK. It could be 1 byte that was an ACK as well. So you just need to put another header in there to distinguish data from an ACK. Now, we don't have to go in and create all of the connection-oriented stuff. We're not going to do a three-way handshake or anything. That's not in the assignment, and that really makes it sort of like a simple TCP anyway. So it's going to still be connectionless. You just want to add the ability to ACK. So you need to do that. So now let's think about what that is going to look like. So we have uh, our client and our server. And a lot of people said, "Hey, I compiled this client and server and it didn't work." So let's look at that. So I'm going to execute the server here, which is BBS, right? And so the server is running there. Let's execute the client dot slash BBC. It says it gives the users, like, you need to put a optional size, and then a host, which is local host, and then a port. And if you look in the code, that port is 5,000. So and then it just returns. It doesn't look like it did anything. So I'm going to add some code to the server because it actually is doing something, but I want to see what it's actually doing. So inside of receive from here, you're going to get, if you look at this, you're going to get a buffer filled right here. And then it echoes right back out that same buffer to the socket descriptor. So what we're going to do is just print out the buffer. So this in here is the number of bytes received. So let's go in and make a simple little for loop, like for int x equals 0, x is less than n, and x plus plus. And what we're going to do is simply output that buffer to the screen. So that is print F. And we're going to output it. Now, if you go in and look, I think this thing is actually putting out basically out the alphabet, but just so that we're good later on, I'm going to just put it out as hex. So a %x, and then we're going to do buff x. And then if we want, we could put out a little bit more information. We probably at the end want a new line. So I'm going to do a simple puts for a new line. So let's save that and stop this thing, recompile it, and execute it. Still got our 5 warnings. We haven't fixed those. And now let's go ahead and do this. Okay, well, so we executed the client over here. Something changed on the server. It put out 61 all the way out. And it looks like it's doing the ASCII alphabet, A, B, C, E, F, G, right? So, but it's in hex so that we can be able to look at anything later if it's binary. So the thing actually is working. So where do we go from here? Well, to move on from here, let's think about what we need. Again, right? We need to add some part of our data segment. You can create something up here, this structure, or however you want to do it, that's going to be an ACK, right? And then when we read in, we're going to see, hey, is this an ACK or is it not? So you'll need 2 forms of your little subheader. Is that one that you can distinguish that it's an ACK, one that you can distinguish that it's data. I will leave that to you guys, right? And that will be probably how I would do it right up front before the data. And then you'll send across, right? If you want to, you can actually put the sizes in there, make things a little easier for you. I mean, it's your header. Do what you want to do. So the next hurdle is it's not really a hurdle. Is when we do on our server side and our client side, since they're both receiving ACKs, in our receive from, we need to check afterwards, is this an ACK or not, and then act accordingly. So you'll just read in that header. Now, the problem becomes, what if you don't receive an ACK? So a lot of people have given me this question as well, is how do I inject errors, right? And some people are talking like coming up with encoding schemes, doing checksums, blah, blah, blah. Don't do any of that. You don't need to inject a 1 by error. All your server or client needs to do to determine that there's an error is you got to simulate it. So to ask yourself, if a socket receives an error, how does it handle that? Well, if you recall from class, how it handles that is simply dropping the packet. So in here, you need some kind of evaluation that at a random interval, and you might want to tool this with your arguments at a random interval, say back down here. So after you get your receive from, say like if rand and modulate that over some value you pull in from argc, right? Or argv. So let's say this is drop. Let's call it drop rate. We haven't declared it yet. Equals 0. Right. So now whatever your drop rate is, if it's 100, 1 out of every 100 packets would drop, right? And then you simply drop your packet. Or you can do a not and not drop your packet, but put some kind of function there to simulate an error. Well, if you simulate the error, then you need to be able to handle that. This is where you would go into your functions of stop and wait or go back in. So that's how you simulate an error. Does not need to be some kind of crazy checksum that you're evaluating. So the next thing that you're going to do is receive from is a blocking call. So if you don't get an ACK, right, then one of your clients or your servers is going to be stuck and not doing anything. So we need to put a timeout in receive from. So a little bit of Googling will help you here. And let's go do that. So let's do UDP receive from timeout, right? Oh, it's right there. It even says, hey, there's those often search from, right? And so first hit right here, this solution works. So it says there's a function called set sock options or set sock opt that takes a socket descriptor right here and sets a timeout. That timeout is based on a value called timeval.tv, which is in time.h. So let's copy this whole thing. And this, by the way, if you go through and read it, this sets it to 100 milliseconds. And so let's go in and stick this in. Well, inside of your code here, this should be commented a little bit more, but right here is your socket creation. And so the call to socket returns a socket descriptor. And so we're going to put this code in right here. Maybe. So here's our time, blah, blah, blah. The only thing you need to change here is it to our socket descriptor, which is SD, right? Save it. And now let's go in and compile it. Right, and so you'll see that, hey, it's still compiled, nothing complained about it, but we haven't seen our error yet. So to show you that this does in fact error, let's just kill the server, which will definitely not reply, right? And we'll do this, and you'll see a receive from error actually show up. Now let's see how we manipulate how long that receive error from is, and that's simply changing the value of seconds. So time value has two fields, may have more, but it has two fields, one for second, one for microseconds. So I'm going to just change this to 3 seconds, save it, and go in and recompile that. You'll see that it pauses for 3 seconds and bam, receive from error. So now receive will only block for 3 seconds looking for that call. And that should give you enough to move forward from here.